This video, we're going to simplify complex fractions. A complex fraction is a fraction divided by another fraction. Method 1 is going to be to rewrite this as division of fractions, like we just talked about in our last video, and then to multiply by the reciprocal, like we have done before. Method 2 is going to be something where we find the LCD of all the fractions that are there and multiply top and bottom by that LCD and clear fractions. We'll show you when we get to a method 2 problem, but let's start off with a couple of method 1 problems. So negative 25x over 24 divided by negative 5x over 4. That's the same thing as negative 25x over 24 divided by negative 5x over 4. So we're going to make this negative 25 over 24 times 4 over negative 5x. 4 goes into 24 6 times. 5 goes into 25 5 times. A negative divided by a negative is a positive. So 5 times 1 is 5. 6 times x is 6x. If you don't like all that crossing out together, then you can go ahead and make this negative 25 over 24 times 4 over negative 5x, and this is going to be negative 100 over negative, and then this is 120x, and divide by 10 first, and then this is 10 over 12x. 2 goes into there 5 times, then to there 6 times, and that's 5 over 6x. You get the same answer. You can take a lot of small steps or a few bigger steps. It's your choice. All right. So that was method 1. This is also going to be method 1, 5 plus x over 20 divided by 5 plus x over 4. It's 5 plus x over 20 divided by 5 plus x over 4. 5 plus x over 20 times 4 over 5 plus x. 4 goes into 25 times, and this is 1/5. Okay. I think I forgot to tell you what section we are in. We are in 14.7 for these problems. Numbers 3, 5, 7. All right, 3, 5, 17, 19, 21, 25, 29, 33, 35. That'll be it. So, and I have finished these two. So now we have r over s plus 1 for r over s minus 1. So I'm going to use method 2 here. Method 2 is to look at the LCD of everything here is going to be s, because these have denominators of 1. They're hiding here. So I'm going to multiply top and bottom here by that LCD of s. And that's going to be s times r over s plus s times 1 for s times r over s minus s times 1. I'm just doing this the first time to show you what I'm doing, and those s's will cancel and leave me with an r. S times 1 is s. These s's will cancel and leave me with an r minus s. And that's method 2. Okay. So This is called clearing fractions. So sometimes we would like to clear the fractions, especially when we have addition and subtraction. In our complex fraction, sometimes it's just easier to multiply by the reciprocal when we don't have addition or subtraction there. So we're told to use method 1 on this problem. So that means that we need to make a common denominator for each of these fractions first and add them together to get a single fraction in the top and a single fraction in the bottom. This is going to be 8x minus 9 over 9x divided by 9x squared plus 10 over 10x squared, x minus 9 over 9x times 10x squared over 9x squared plus 10. And an x divides out, leaves me with 10x times 8x minus 9 over 9 times 9x squared plus 10. And that 9x squared plus 10 doesn't factor anymore. So this is simplified. All right, let's try method 2 on this problem. 3 plus 9 over y minus 6 over y plus 9 over y minus 6. My LCD is going to be y minus 6. This is going to be 3 times y minus 6 plus 9 over y times y minus 6 plus 9 is going to be 3y minus 18 plus 9 over y squared minus 6y plus 9 is 3y minus 9 over y minus 3 squared is 3 times y minus 3 over y minus 3 squared. So that leaves me with 3 over y minus 3. That's my final answer. Give you a second to look at that. All right. Zoom back in here. All right. Now let's look at this one. X over y plus 1 or x over y minus 3, and they tell us to use method 2, where LCD here will be y. So this is going to be x plus y over x minus 3y. This problem's a little more interesting. We have fx plus fg over x squared minus g squared over x plus g, x minus g. I want to go ahead and factor and simplify a little bit first. X plus g, x plus g, x minus g over x plus g, x minus g is going to be f over x minus g over x plus g over x minus g. They already have a common denominator, x minus g, that I'm going to multiply by, and that gives me f over x plus g for my final. That problem would have been a lot harder if we didn't simplify first. All right, now we have 2 plus 6 over x over 1 minus 9 over x squared. And we are told to use method 1 here. So I need to multiply by x over x here and by x squared over x squared here. And that gives me 2x plus 6 over x divided by x squared minus 9 over x squared. This is 2x plus, this is 2 times x plus 3 over x divided by x plus 3 x minus 3 over x squared. That gives me 2 times x plus 3 over x times x squared over x plus 3 times x minus 3. X plus 3's go out. One of the x's cancels, leaves me with 2x over x minus 3. So take a look at that. Again, that was a method 1 problem where we made a common denominator in the numerator and a common denominator in the denominator, wrote it as a single fraction divided by a single fraction multiplied by the reciprocal and simplified. And this last one is going to be a method 2 problem where we're going to clear the fractions. So 2 over x plus 3 plus 2 over 8 over x plus 3 minus 2. Our common denominator is going to be x plus 3. That's going to be 2 plus 2 times x plus 3 over 8 minus 2 times x plus 3. Give me 2 plus 2x plus 6 over 8 minus 2x minus 6 is 2x plus 8 over negative 2x plus 2 is 2 times x plus 4 over negative 2 times x minus 1. Negative 2 goes into 2 negative 1 times and leaves me with a negative x plus 4 over x minus 1. All right, next time when we come back, we will talk about how to divide a polynomial by a monomial. That will be a topic from chapter 12, 12.7. So come on back and we will talk about that next time.